This is another free tutorial video from CBIS Visual Technology. In this video we will discuss 3D diffusion effects created in thinkingParticles 6.7. Before we start, let's have a look at the scene. So what we have here is a container with a fluid in it, and we have these 4 colored tablets. What we are trying to achieve is we throw these tablets in and we want the color of each tablet to diffuse inside of the fluid. This setup was done with a simple PostionBorn where we created the particles and we used the InitialState operator to create a settled fluid. It's very easy to create a fluid at rest with the help of the InitialState. All you need to do is do some simulation steps and then store it to the hard drive. So that's what was done here in this scene. The next important step is for our fluid. We wanted to assign 2 data channels. One channel to specify the color of our fluid and another data channel to give the color a weight or a strength. So this is done with these 2 data channels. And one data channel is channel 0 where we store the color, and another one is the weight color channel. That's our data channel 1. This is important so that every particle can hold its own color and weight. The next dynamic set we have inside here is for creating our tablets or our colored tablets here. So all these 4 tablets are created with the MatterWaves, or we bring in MatterWaves and create particles on the surface of these objects. So these little chamfered cylinders are used to create particles. Each particle we create in MatterWaves will get its own data channel 1 and 0. And in data channel 1 we keep the weight, the color weight or strength of the color. So we want to make sure that color strength is high so that our tablets, when they drop into the fluid, give up their color. And we define that with MatterWaves. So we say, okay, color channel 0. So each particle we create on the surface of the tablet will store its color automatically in data channel 0. And that's all about the little magic we have here. So we create those particles on the surface on each tablet. We pick the color from the surface and we assign it to the particles we just created. And this information is stored in the particles in the data channel. Let me just show you the particles we actually create here with ticks on the surface of our tablets. So you can see here the particles. Let me just go to wireframe so it's easier to see. And then the tablets are falling down, and the same with the particles on the surface. So we recreate the particles all the time. So we would be able to have even animated colors, or any texture would give up their color into the fluid. Just hide the tablets as well, so you only see the particles, and that's the key to our color diffusion in the fluid. Next thing, let's turn off the particles. So we don't want to see the particles we create from MatterWaves. We just want to see our little color tablets. And let's have a look how we actually do the 3D diffusion of our color values in 3D space, in the volume of the fluid. So for that, I'll turn off the fluid particles as well, so we no longer see the fluid particles. And let's go to the next step. How do we actually distribute color information in 3D space? We use our AllPurpose Fields. It's a very simple setup. We set up a 3D field that stores our color, and we use the APF input from and APF output to. The input from is we take the color information from the particle. So the closest particle to a 3D cell will take the color from the particle, and we output the color as well to the closest particle in a cell. So it's actually the particles that transmit or transport the color information throughout 3D space. Keep that in mind. That's the important part. The fluid particles transport the color information between the cells. And now let me just display the cells with the show cell option in our all-purpose field. So every dot represents the center of a cell. So this is how the 3D space is right now divided. So it's pretty accurate. It covers all the area. So these are not our fluid particles, keep that in mind. It's just the grid points of our all-purpose field. So every field stores the color. And now we can see our MatterWaves particles we have created in the step before. They are now passing on their color information to the cells. And the cells itself pass it on because the particles move also inside of the volume, or they are close to each other in the volume. Right now, keep in mind, we are not seeing the particles, our fluid particles, we just see the cells. But you can see how the color information is transported from cell to cell. So it's fading to the corners, and over time this color exchange in 3D space will continue, and all of our color will be diffused inside of the fluid. So that's the basic setup of our field. So important, once more, let me repeat, the particles are passing on the color information inside of this 3D space. And this 3D space is divided with an all-purpose particle field, and from cell to cell we pass on the color information. And we do that with our data channel, where we stored right from the beginning the color information. And the input from will store the color, output to will put out the color to the cell. Next step, we want to see actually the color diffusion in 3D. And that's the new thing. We could see the color on the surface, but we want to see it in 3D, and it should mix in the volume. For that, we are using our SmokeRenderer. thinkingParticles comes with its own atmospheric SmokeRenderer. The operators we are using here is the smoke group operator, the smoke render, and the smoke T-ranges. The smoke group is used just to render the particles. We are not doing fluid simulation with the smoke render right now. We just want to use the atmospheric renderer part. So we specify the particle group and the solver. All the rest is not relevant right now. Then we use the smoke render to adjust our rendering, the look of the rendering. And the smoke T-ranges are just there to give an initial white color, because we want to color it through our particles. This is the basic setup we have here, and that will allow us to render true 3D atmospheric effects. So volumes will properly mix and add up in 3D space. So here we have this nice volumetric rendering, and let's do some little adjustments to get it a little bit faster in rendering. So I'll turn down the radius, and you can see it has this impact, so it looks now a little bit blobby, or we can see the particles. We can get rid of that and still keep the fast rendering speed by using the jittering, and that gives us a nice tint-like or color-like diffusion effect. And then we turn on all the effects we want, shadows, self-shadows, and whatever we want, including the density of this effect. The density, let me just reduce the density. That will give us a little bit more a view of the templates here. So the density is a very important setting we have here. I just turned on the surface of our fluid. It takes a few seconds to rebuild the surface. We can see that in the viewport. This is our fluid surface. We don't need to see it actually in the viewport, so I'm going to turn it off in the viewport So I'll go to our particle, fluid particles, and turn the show mesh option off. So now the surface is gone in the viewport. So I can do much faster simulations now because it doesn't have to redraw always the fluid surface. And here we have some nice color already in there. Let's start the rendering and have a look, including the surface. We're using the scanline renderer with the ray tracer, which comes default with 3D Studio Max. So we can see here now our atmospheric rendering. Keep in mind we adjusted in the smoke render our density. Even with the lower density, we can see that we now get a really dense atmospheric effect, and that's because of the refraction, reflections and stuff going on with fluids. Let's advance the animation a little bit more to get more colors into the fluid. Same deal here. Real 3D volumetric diffusion of colors. The particles are transporting the colors throughout the 3D volume. Let's start another rendering. And here we have more colors. And over time, the particles will pass on their color information, and it will eventually diffuse into a mixed color value. One more thing I would like to discuss or show you here in this tutorial is this little debug dynamic setup we have here. So we are using the viewport color, and we are grabbing the color from the data channel 0. You remember, this is the data channel where we store the color of the particles. This little setup will give me the advantage that I can see actually in the viewport how the colors are distributed among the particles. So that's all I need to do here. And when I turn off this debug dynamic set, and I'll go back to frame 0, we will just see our default visualization mode where we see the pressure of our fluid. So right now I only see the pressure values, which is not giving me any indication that we have a color diffusion going on. When I turn it back on, I actually see the color values each particle has. And I can even see how it's distributed in 3D throughout the volume. So this is a very powerful feature. And I could also visualize the weight, but the weight doesn't change for the particles. But keep that in mind, it's really helpful to actually display values in the viewport. And this wraps up our 3D diffusion tutorial video for thinkingParticles 6.7. Thank you for watching this video. I hope you find it useful. Check out our other tutorials as well.